Okay, I hope you're ready for this. You might want to get something to drink. You might want to have a little snack because this is going to be a long one. This is going to be pretty intense too. We're going to be graphing sine. Now what happens is sine is typically this picture where we start at the origin here. We go up to a maximum, then we come back down to the axis. Then we go down to a minimum, come back to the axis, go up to a maximum, come back to the axis, and keep on going. And we can go in the other direction the same way. Okay, now your job when you're doing this is to first off identify what we call critical values. Now critical values are where the graph crosses the axis, the x-axis. It's also our maximum points, which will always be going to the same point, and our minimum points, which will always be going to the same point. Okay, so that's what you need to do. You need to identify what these are going to be. Once you identify those points, then we can just draw in the graph and we've got our picture. Okay. Now, sine is cyclical. What that means is if I start here, I go up, down, up, and then I'm going to start over again with the exact same thing I had right here. Okay, so this right here is one cycle. If I go right here, this is one cycle. Okay. And so when we talk about from the start to the finish, well, if you could see my fingers, I'd be having quotations to the finish. This is called one period, okay? And a period for sine is 2 pi. All right, and if you think about that, if we have a circle in radians, we're going around all the way around 2 pi. And I'm going to be working radians here. We do not work in degrees usually. We work in radians when we're graphing sine. Okay, so one full circle is 2 pi, and then we would start over. And because the circle is cyclical, because once I get back to the first quadrant, it's going to be the same as when I was in the first quadrant the first time. And the same with the second and the third. And so that's what's happening here is once we get to 2 pi, it's going to start over again going back in the first quadrant. So that's why it's cyclical like that. Okay, so the period is usually 2 pi. Also, if you think about on the unit circle, once again, if you look at the unit circle, sine is the y value. The biggest your y value gets is 1, and the smallest your y value gets is -1. And so normally sine will be at 1, and our minimum would be down at -1. That is typically what our max and mins are for sine. So it starts at the origin. It goes up to a 1, goes back to the axis, down to a -1, back to the axis, and back up to 1. Okay. The other cool thing about these critical values is that they're all exactly the same amount of space in between them. Okay, so if we look at the spaces, I'm not counting the points themselves. There's actually 5 points here. But if I look at the space in between the points, I've got 1 space, 2 spaces, 3 spaces, 4 spaces. So I've really got 4 spaces here. And if I have 4 spaces, that means I'm going to take the period, divide it by 4. So 2 pi divided by 4 gives me pi over 2. So that means if I start at 0, then this one is at pi over 2, and this one's at, I'll add pi over 2 to that, you get pi. Add pi over 2 to that, it's 3 pi over 2, and then add pi over 2 to that, it's 4 pi, or sorry, I lied, 2 pi. Okay, and so one full cycle of sine then goes from 0 to 2 pi, stopping at pi over 2's every time to give us the critical values. So that was kind of intense talk. We're going to go through it step by step here in the next part. So we're going to be changing things. See, now typically when I graph sine, so if I just graph sine as it is, okay, we said we started at 0, then at pi over 2 we went up to the maximum, that would be at 1, and then at pi we went back to the axis, and then at 3 pi over 2 we go down to the minimum of -1. And then we get back to the axis at 2 pi. Okay, so that's pretty typical. Now, if I wanted to change how high or how low it went, what I would do is I would change what we call the amplitude. Okay, the amplitude is telling us what is our max going to be and what is our min going to be. In order to do that, what I would do is I'd multiply by a number in front. So let's just say I want to multiply y equals 2 sine theta. Okay, so what that means then is I'm still going to have these exact same guys, same spots there, but instead of my maximum being 1, my maximum is going to be 2, and my minimum is going to be -2. So this maximum dot is going to go up here, and my minimum dot is going to go down here. So I go axis, axis, maximum, axis, minimum, axis, and then I can graph that in there. And so this would be my new graph. Okay, and then I could continue going on in other directions. I could also do one, let's say it was y equals -1 sine of theta. So now what's happening is instead of going up to 1, I'm going to go down to -1. Okay, so here instead of going to maximum, I'm flipping it over, I'm going to a minimum. And then where I would normally go to a minimum, I'm going to go to a maximum. The rest of the axes are just fine. So these guys all stay the same. So then I would be going like this for my sine wave. Okay, so that's amplitude. Okay, then we have the change of the period. So if you remember, I told you that the period equals 2 pi. Right, so from here to here is 2 pi. And then I said to find these guys in between, we take the period and we divide it by 4. We're going to call that width of the quarters, is taking the period and dividing it by 4, and so we get pi over 2. So if I start at 0, then I get pi over 2, and if I add pi over 2 to that, I get pi. If I add pi over 2 to that, I get 3 pi over 2, and if I add pi over 2 to that, I get 2 pi. But sometimes we want to change that. Sometimes we want it to be shorter. Okay? And so let's say that I said we have sine of 2 theta. So if I multiply the theta, last time I multiplied in front of sine. If I multiply in front of theta, then what I'm going to do is I'm going to find the period. Instead of being 2 pi, I'm going to take 2 pi divided by the value I multiplied in front of theta, 2. So now my period is just pi. So that means I'm going to start here at 0 and I'm going to end here at pi. Okay, so I'm scrunching this sine wave so that it's shorter. And so then when I want to find the width of the quarters, I'm going to take my new period, pi, and I have to split that into 4 parts. So you'll see that it's actually pi over 4 now. So if I start at 0, then I have to go to pi over 4. And then I add pi over 2, so I'll still go there. And then I add and I get 3 pi over 4. And then I add again and I get to pi. And so now, boy, oh boy, here I need to go up to 1 and down to -1. So I start at the axis, I go up to the maximum, then I go to the axis, down to the minimum, and back to the axis. So I go up and back down and back up. So I got that same wave, only now it's a lot shorter than the other one. And the only other thing to tell you about this is if the number in front was a fraction, so if I had sine of 1/2 theta, I need to find the period. I need to take 2 pi divided by 1/2. And if you divide by a fraction, you multiply by the reciprocal, so we get 4 pi. Okay, so now it's way out. I've actually run out of room. It's going to be way out there. This is only going to be halfway. And then to find the width of the quarters, I'm going to take the new period and I'm going to divide it by 4. Remember, it's 4 parts. And I would just get pi. So that means I'd start here. My next spot would be here at pi. That would be my maximum. Then I'd add pi again. I get to 2 pi, so that'd be the axis. Then I'd add pi again. That would get me to 3 pi. That would be my minimum. And then add pi again, and that would get me my maximum. And you can see I've run out of room here for that sine wave. So that's how you change how long it's stretched out to be. Okay, this is the really fun one. So if you notice, I have sine of theta plus c inside the parentheses. So what I'm doing is I'm messing with the angle itself. And this is my angle axis. So by adding c to it, I'm changing where the angle is going to be. So I'm like basically picking this up and moving it. Unfortunately, I can't do that. Let's see here. Let me try this. So let's say I put that in there. What I'm doing is I'm taking that, it's not going to let me separate them, shoot. I'm taking that green line and I'm going to be moving it. So let's just show you an example. And this is really weird and it's kind of confusing, but let's say I have sine of theta plus, oh my goodness, what was that? Theta plus pi over 2. Okay. So instead of starting at 0, like I normally do, we are now going to have to subtract pi over 2 and start at negative pi over 2. Now that seems weird because it's a plus there, but I'm being serious here. You have to actually subtract. When it's inside the angle, when it's with the angle itself, you have to go the opposite direction than what it says. So if it says plus pi over 2, we're going to start at negative pi over 2. That's my first critical value. Okay, and then I have to go back to figuring out my period. Now, there's no number in front of the angle here, so my period is going to be normal. It's going to be 2 pi. And then my width of my quarters is divided by 4, so it's going to be pi over 2. So that means I'm going to add pi over 2 every time. So remember, I'm at negative pi over 2. So if I add pi over 2, I'm going to get to 0. And then I add pi over 2, I get to pi over 2. And then add another pi over 2, I get to pi. And then add another pi over 2, I get to 3 pi over 2. And I'm actually going to stop because I have 1, 2, 3, 4, 5 critical values. And so then I graph sine. We go up to 1 and down to negative 1. So I start on the axis. I go up to the maximum, axis, minimum, axis. And so here is my new sine wave that has been shifted over. Okay, so we call this our horizontal shift. And so it's shifted over to the left, which is the opposite of what we would think it would be. We actually call this our phase shift. Okay, so a lot of times you'll see me say phase shift. Okay, and then we have one more shift. I know this is over, isn't it? But we have one more shift, and that is if instead of it being inside with the theta, it's saying all of this plus d. So I'm not adding to the angle, I'm adding to the function itself. And this one actually isn't all that bad. Let's say I had sine theta plus 2. What that means is instead of having my axis be right here, I'm going to shift that up, and it actually goes with it this time. I'm going to shift it up too, just like you think it would be because it says a plus. So then everywhere that I would normally have my my critical values, they're just going to be up here a little bit higher. So it's 2 up. And so then I would go up. It's just 2 up from what it normally would have been. And so then there would be my graph. Okay, so it looks exactly the same. It's just shifted up a little bit. Okay, so let's look at a full-on problem that has a whole lot going on here. So this is going to be an intense problem. I'm just warning you ahead of time here. Okay, so let's take some notes. We have an amplitude. Our amplitude, remember, is that number in front of sine. So our amplitude is 2. So that means I'm going to go up 2 from the axis and down 2 from the axis. Okay, then we have the period. And the period is where we take 2 pi divided by the number in front of theta, so divided by 1/2, which means I'm going to multiply by the reciprocal. And so then I get 4 pi, which means my width of my quarters, remember I'm going to take the period and I'm going to divide it by 4, so the width of my quarters is pi. So that kind of is nice. But then we have a problem because we have a phase shift. Remember, the phase shift is what's inside the bubble here, and that's always the opposite. So to denote the phase shift, we're going to go pi over 2 to the left. So I'm going to point to the left because positives and negatives get kind of messed up here. So I'm going to point to the left, saying that my phase shift is going to go to the left. And then I have a vertical shift, and my vertical shift, remember that's going up or down, I have a -1 at the end, which means it's going to be 1 down. This one actually goes with the sign that it says. Okay, so we've taken all our notes. Now it's time to graph. It's a pretty big one because it's a period of 4 pi, but I also have a phase shift to the left. So I have to start at negative pi over 2 because that's what my phase shift said to do, is start at negative pi over 2. I have to add on pi every time. So I'm at negative pi over 2, and I suggest you do this. Add on pi. I'll have to get a common denominator. So if I add on pi, I get pi over 2. So let's see here. I need to make sure I space things appropriately on my page here. And then I have to add on pi again, which is 2 pi over 2. So I get 3 pi over 2. So make sure I space accordingly. And then add on 2 pi over 2 again, which gives me 5 pi over 2. Space it appropriately. And then add on 2 pi over 2. Remember, I need 5 of these, so I get 7 pi over 2. I think I have 5. Let me count. 1, 2, 3, 4, 5. Notice the axis is not one of them, so I'm not going to put a dot on the y-axis at all. I go 1, 2, 3, 4, 5. Okay, then we have, so the period's taken care of, the width of the quarters taken care of, phase shift is taken care of. Now we'll do vertical shift. It says it's 1 down, so I'm going to go down here and I'm going to put in a dotted line right here to denote for my new axis. And then my amplitude is 2 from there. So my amplitude goes up to 2 from there, so I'm going to go up to 1. Remember, this is -1. And then it goes down 2 from there, so now I'm at -3, so I'm going to label those. All right, now to graph. Okay, this is sine, so we start at the axis, only we had a phase shift, so it starts right here, axis. Then on my next one, I go up to the maximum, then the axis, then a minimum, I'm making sure I go 2 away, and then the axis. And so there is the graph of sine. We will practice this lots. Good luck.